start from the logical physics Surganov. It's for Ministry Health of Republic of Belarus State Medical University. It's for foreign students of the first year. Yes, this is I will be a lecturer on this book, Medical and Biological Physics, for you. Here is the content, so all the physics, and we start from three: mathematics and physics used in literature. Yes, okay, I'm going to make this bigger. We need to have some assumption about elementary mathematics and physics. So we use elementary mathematics equal circle, law or property, speed, velocity, argument, increment, law, decimal log, yes, logarithm, logarithm, tans, fx, tangent, arcsine, cotangent, arctangent. Yes, information, physics, area, root, function, acceleration, sign, symbol, graph, diagram, logarithm, natural logarithm on the exponent in the basement, cotangent, arctangent. So we use the right rectangular triangle, and we use such equations which are useful for this triangle. So sinus, it's nearby this right angle. Yes, we have to use these words to sign termine. It's a little bit of making short of Latin semi-recta incrypta. So it's a semi-hordos, it's half of the hordos of the circle. And the cotangent is the going from Latin complementi tangens, what means tangents of addition. The cosine is going from Latin complementi, there's something additive to sinus. Yes, and tangent, it's going from Latin something what have to touched to the curve, something what touches to curve. Yes, and exactly this type of the mathematician example, what we have to use the tangent, it will be our slope of our curvature or line, yes, of our figures. And this relationship between them and the sinus square root of alpha and plus cosinus square root of alpha will be equal to 1. So we have theorem of sinus here. It's just to refresh your knowledge about your school trigonometry. Yeah, again, it's something, the term, it's about the from Latin. Yes, also it's something about the measuring the triangles. So it is work with triangles and the angles inside, that is triangles, sides of triangles, and what relationship do they have inside these triangles. So it's it's the theorems of sine and cosine. It's about for every triangles. The first one only for the right triangles with the right angle of 90 degrees, and this degrees is not this degrees about the temperature, it's the angle degrees again. So you remember all the things. I hope I just refresh your knowledge about the area of the circle. It's uh, how to find a square of this circle. We need to make the ratio between the line, the length of the line on the around the circle and the radius, and we know that it's a p, it's number p, irrational, very long ratio, but sum of mathematical constant, fundamental constant of our universe, and we just make some part of this very big set of the numbers, and we make the p equals to 3.151. It's 14, 15, 90, 25, it's something like that. We just make it 3.14, and this quadratic equation is x squared plus px plus q, so equals to 0. Roots of this quadratic equation is making, you don't forget making discriminant, and we need to or you can to take the Weit's formula, and you receive two roots of this quadratic equation, which will be equals to this formula, minus p divided into plus minus, so two roots. Yes, plus is one root, and the minus will give us second root is a square root from the or root of p divided on 2 in the power of 2 minus q. So definition of logarithm. A logarithm on the basement b of a will be c. It means that b in the power of c will be equals a. So it's the definition which some mathematical formula which give us the first meaning of the power in which we need to make the basement. Yes, how much time we need to multiply basement out itself to receive your a. Yes, to receive the concrete result. So it returns the first numbers and the meaning of the power. If b will be equals e, it's some second fundamental mathematical constant exponent, second fundamental mathematical constant of our world will be so the also ratio, yes, about the 2.718, yes, and it's also very long set of the numbers, but we use only actually we often use 2.721 or 72. It could be. So we used only 2 or 3 numbers after a comma actually. So this, if we have the basement, its exponent in your logarithm, you will receive the natural logarithm of the number a. It will be the c. Yes. So you have the same properties of logarithm, something like the properties of the powers. Yes, the formula of powers. So the additive and could be minus set, and if you have division you will be minus set of them, and you can play with the powers inside logarithm and they go outside of it. So you could remember that formula of the square power of sum or minus sum, so division of, and there is the relation between the powers a in the power m multiplying on a in the power m will be the a in the power of the sum of these powers, and the ratio will be the minus inside the powers. So the table of the meaning of the sine and cosine, some trigonometric meaning of the sinus, cosinus, tangent, cotangent, some angles, exact meaning, and the exactly what we trying to do about the derivatives and how it works in physics. So we use some example of movement of the body with some speed, and the speed will be your some difference between changing on the replacement of the body on the some units on the time. So you need to divide the change of the your coordinates, how much they move. It moves from the some first place, and you need to divide it on the period of time when this changing of the place is going. So it's the speed, how fast the body changed its replacement, changed it place. Acceleration, we have the second derivative from the changing place, or the derivative from, so it changed at something like differential of the velocities in the nominator, and the change of the time at the period of time of this change of velocities, how fast it's going on, the change of the rate. So the second law of Newton, we remain this, the F is equals to ma. So the power, the force what is acting on the some body, it's the equals to mass of this body and the given of this forced acceleration of movement. And the Hooke's law, it's the force what acting on the body, it will be the elongating of the body, x on the some stiffness of the body. It's excuse me. Да бери быстрее, ну. So if it's a function of the x, where y is equals to f depends on x, where the y is a function, x an argument, and delta x is the increment of argument. So delta y is right equal to delta f. It's the increment of function, and the incremental function will be equals to function depends on x plus the increment of x.
Второй телефон.
Не знаю. The f minus fn on the x. So if you have the y equals to kx, it's something like linear function where k is a constant, the graph of linear function in the straight line. So you have some curvature on the graph on figure 1, and there is some formula to make the mathematical assumption, mathematical picture of what happens here on the Cartesian coordinates of some curvature. So we need to explain, to have some vocabulary about continuous function and limit of the function. Derivatives, its mechanical and geometrical sense. So we have some words, something like continuous, possible, paper, some infinitesimal, as things, specified, cheering off, point, if, and then. So derivative, discontinued, neighborhood, the sense or meaning, mechanical, tangent, theorem, let, proof, finding, average, instantaneous, second straight line. So we have the definition about the this continuous of the function. The function y equals to f depends on x. It's called continuous in a point x0 if it is determined in the neighborhood of this point and delta y is going to 0 and delta x at 0. For example, we have two variants of continuous function of a and b, and c is discontinuous function in the point. So continuous function delta x is going to 0. Going to 0, and delta y is also going to 0. Look at that. Okay, and the continuous function also have the x is going to 0. Yes, and delta y is going to 0. Discontinuous function in the point of x0. You have this special type of the movement. Then we have cheering off here, cheering off of the graph here in this point. So it have something like some asymptote. Yes, we have graph tendence to this line but never cross it. So tearing off in this point of z0, the graph a continuous function apparently from x. Figure 2 and figure 2b, it's possible to draw no tearing off pencil from a paper. It's something like that. Definition, and number a is called the limit of the function f of x. The x is going to x0 if function will be equals to f big will equals to f depends on x. When x not equals to x0, it exactly is a. Yes, when x equals to x0, it continues in the point x0 when we have limit of x going to x0 very fast, and f on depends on x will be equals a. So the function f is continuous in the point x0 when a, for example, it is possible to take equals f depends on x0. So in other words, we will have a equals f depends on x0, and the limit of the f at x when x going to x0 equals a. So it will be equals to f depends on x0. So examples: limit of x in the power of 2 when x have 2 x0. So will be a function of x0, a function of 2. 2 in the power of 2 is 4. So another limit, we have the 1 plus 1 divided on x. X going to infinity, and the limit of it when x going to infinity. We have to divide this limit on two limits. The sum, it's additive function, so we have limit of 1 when x to go into infinity plus limit of 1 derived on x when x go into infinity. So we when x going to infinity, this ratio will give us something which going to 0. Yes, the more it's going, x is going to infinity, the x going slowly to 0. And so we receive 1 plus 0, it will be equals 1. So we have some limit here, some tendance line of the graph, which is going to here, and but it's going to across this line somewhere where infinity is going, when the x is infinity. Here is using the property of limit of this borderline of the meaning of set of x. Limit of the sum of function is equal to the sum of limits, and the limit of a constant c at as c is 1 is equal to this constant. So definition will be like that. The function a depends on x. I will call it infinitesimal if the limit of a of x when x going to x0 equals 0, or limit of a of x when x going to infinity is equals 0. So example, function a of x equals to x minus 3 will be infinitesimal at x going to 3. Yes, if x going to 3, and this function x3 minus 3 will go into 0. Since we have this limit when it's x is going to 3, we have the x minus 3 is going to 0. A of x will be equals to 1 divided on x will be infinitesimal at x going to infinity, since limit of 1 divided on x when x going to infinity is equals to 0. So we have this theorem then we have some limits. If we let limits of function of the x equals a when x going to x0, then the function of x will be equals a plus alpha x, where the alpha is in infinitesimal. So geometrical illustration of this theorem on the figure 3. So we have some alpha x and some a. Yes, it's exact meaning of the interval on the line a, and some interval where the function of the x strongly depends on x when alpha on x is infinitesimal. So geometrical illustration of the theorem is on the figure here. Definition: the derivative of the function of y equals to f depends on x in the point x is the limit. So derivative of the function f prime x will be limit of this differential x f divided on differential x when differential x is going to 0. This delta x is going to 0. Another limit, yes, of this ratio between the f depends on x plus differential x minus f depends on x divided on this differential x. This differential x is going to 0. I remain. Differentiation is operation of finding of a derivative. So physical sense of derivative, again, remember that let the body moves along the axis x with the average speed, yes, and this average speed where is equals to this differential of the s, yes, of the wave moving and divided on the delta t, yes, the interval of time when this happens. So we need to make the ratio between the s depends on t plus delta t, this interval of time, minus s on t, and divided on this delta t. If to reduce an interval of time delta t, in other words delta t is going to 0, speed of a body at present time is equal to the limit the velocity of instant will give us the limit of delta t going to 0, delta s divided on delta t. So this speed is called the instant and express the mechanical sense of a derivative. In general, derivative will be equals to speed of change of a function. Speed of change of a function. So we have there another graph. We have through 2 points on the graph of function. Y will be equals to f depends on x on the figure 5. We shall lead a second straight line m0 m. If the m is going to m0, when second here straight line will borrow position on the tangent which has been laid in the point of m0. From this special type of triangle delta m, the triangle is m and m0. The tangent of this phi inside this triangle, it will be a ratio between lengths of mn, here is that, and m0n, and the m0m will be this hypotenuse of this right triangle, yes. So we need to have tangent, we need to divide this line with opposite of this angle and something nearby the angle, yes. So we have this delta f the change differential of the change of the function, and the change of the argument delta x. Here is the projections of it. Here is m0 x0 here, and m, it will be x0 plus this delta x, and the delta x here is the interval of the change of your argument of the function. Let will be m going to m0, then tangent. So let this slice of the function become very tiny. It's going to this point between them, the very small interval. So then if we have nearby here these 2 points, we then your tangent of the phi is going to tangent alpha. Yes, it becomes more and more going to right angle. Yes, something with 2 points going to each other, and this angle is going to, the slope is going up, 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 up. Yes, and then the tangent alpha, it's something which touched this curvature in the point of m0. Yes, this angle of the slope m0, and the phi here, and this it's more convenient to have the difference between them in this when they cross the x-axis. So we have tangent of alpha, there will be limit of delta x going to 0 when of delta f divided on delta x, delta f divided on delta x. So last formula, we need to make it this smaller, 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 smaller to make this point coincide m0 m. So this very little tiny slice of the curvature is this physical meaning of the result. So last formula express a geometrical sense of the derivative. The derivative from the function in that given point, it's equal to the tangent of the angle of the inclination of the tangent this point to axis or axis of abscess here. It's a difference between them, and we need to go in here. This point, it's going here. The slice delta x, it's going to 0 very fast. Very small, very tiny, and something like that. So general rule of differentiation table of the basic derivatives and derivative of the composite function. So again, general differentiation, intermediate, rule, and composite. Use a general definition of derivative. For finding derivatives, it is necessary to make the following steps. So it's necessary to make these steps. 1, to give the to it x the increment of delta x, and to find to meaning of the function when f of x plus delta x. Second, you need to find the increment of the function f of x, delta f of x. F depends on x plus delta x, minus m depends on x. 3, to make the ratio delta f divided on delta x. So f depends on x plus delta x minus f on x divided on delta x. And 4, you need to find the limit of the ratio at delta x is going to 0. It's f prime on x, it's equals to limit of delta x going to 0, f delta f divided on delta x. So when you're using, in example, when you're using the general rule to find derivative on the function y equals x squared, you find 1 x depends on f depends on x plus delta x, it's equals to x plus delta x squared. If delta f will be equals to this rule will be the x plus delta x squared minus x squared, and you will see the result of the square power of sum, and you have some mathematical changing on transformation. Here we'll receive the 2x multiplying on delta x plus delta x squared, and the x in the power of 2 will be cancelled, and the delta f divided on delta x will be equals to 2x multiplying on delta x plus delta x squared divided on delta x. The result will be 2x plus delta x. Yes, so we have cancel it in the first part of the sum, and cancel it 1 power here in the second part of the sum, and the limit of 2x plus delta x when delta x is going to 0 will be a limit of delta x going to 0, and we have the sum of two limits of 2x and delta x here, and the result will be 2x plus 0, because delta x is going to 0, the result will be delta x. For simplification of finding of derivative, find the derivative for the basic operations and formula. Some of them, yes, some from them will be here on the table, and you have this table of derivatives. It's already made for you for thousands of people before, and everything is right and works well, so you can just take the part of your derivatives into this formula and receive the right result. So example, y equals to 5x minus in the power of 7, yes, and minus 6 sinus x. So what is derivative of it? Y prime will be equals to the derivative of first part, 5x7 in the power of 7, and minus the 6 sinus will be also in the power of prime here in the meaning of the derivative. So we receive from this formula that x in the power of 7 will be the 7 multiplying on x in, yes, here 7 going here, the 5 is still remain because it's constant, and 1 will receive that we have also 6 multiplying on, what is this sign, the power will be cosine, so 6 just multiplicator here. Composite, if it can be submitted as function from function, we will have y equals of the function of the x. It's the u, some intermediate argument, for example. It's squared, it's elementary function, composite x plus 3 squared. So we could use like u, something like u, which equals x plus e, it's u. So y on u derivative will be y on it, or transfer on u will be u squared. So elementary function sinus x, composite function sinus 5x, so u will be 5x, and y on u will be sinus u. So theorem 2 will be let function y of f on u, function of u, and the phi is the function of x, it's equals u. So they are differentiated in the corresponding points. Then the derivative of composite function will be y equals to f depends on phi on x. It's equals to some like chain rule. So derivative of the y on x will be equals to derivative y on u plus multiplying on u derivative on x. So we call it chain rule. So we need to make a derivative from inner function on x and multiplying the outer function on u. Yes. So example, sinus 5x, u will be equals 5x. So derivative of sinus of u will be multiplying on the derivative of u on x. So cosine 5x, yes, the result will be cosine of u, and multiplying the derivative of 5x, yes, only 5 will remain. The 5 cosine 5x. Derivative of second order and its mechanical sense. The derivative of function of y equals f depends on x. It's named a derivative of first order. This derivative is function from x and it can be differentiated once again. So if second prime on x will be f prime on x, yes, and the second derivative. So it could be differentiated once again on the x. It's equals to it's going to something like d in the power of 2 and the x in the power of 2, but it is meaning of it writes the derivative of second order on the function on depends on x, and you could write the y2 prime or this scratch, yeah, something like that. Why you have to write the point if you have the derivative on the function of the time, so you could make in point to explain the derivative. The first one point is derivative of the first order, and the second point the derivative of second order on the function of the time. The derivative from a derivative, it's known as derivative of the second order again. It is similarly possible to receive a derivative of the third order, etc. The derivative of nth order is designated as n in the power of n. Yes, it's something like n prime f in the n prime x. Example, y is equals to x in the power of 3. y prime will be 3 in the x squared. y2 prime will be 6x. y3 prime will be 6. y4 prime will be 0. Yes, so the rules is the same like that in this table. We widely use them, but you have to make a derivative of the next order till it's disappeared here. Let's find out a mechanical physical sense of the second derivative. Let the law of motion of a point along axis OX is expressed by the equation x equals to f function of the time. So the average acceleration of rectilinear motion in the time delta t, it will be the ratio of so the acceleration average will be the ratio between delta v divided on delta t. So the limit of the ratio, yes, at delta t interval of time will be going to 0. It's known as instant acceleration, a instant of the point at this moment of the time. So you have to write the limit of delta t going to 0, the differential of v of velocity divided on differential of t of time, period of time, and this period is very very tiny. It's going to 0 at this moment of time. Yes, instant acceleration. And this v prime on t, it will be equals to instant acceleration, a instant. A instant is the first derivative of velocity, depends on time, and the second derivative of distance, changing of distance, x. Yes, second derivative, x2 prime. So the second derivative from a distance x with respect to time is equals to instant acceleration of rectilinear motion of mechanical sense of the second derivative. Here is that. So we need to research the function on extremum, the maximum and minimum. Maxima and minima is also Latin words of extremum. The function, some extremal, yeah, some extremal meaning. It's named its extremum, also Latin. For research of the function on extremum with the help of the first derivative, it is necessary first to find a derivative of function f prime on x, to find a root of the equation, yes, the critical point x0 f prime on x with respect to x equals to 0. If the derivative at transition through a critical point x0 at increase x, change it mark plus or minus, it could be minus, or minus or plus. So we change the sign, we change the mark, plus on minus or minus on plus. Then the point x0 function has a maximum when plus or minus, maximum, and when minus on a plus, minimum. Yes, if at transition through the x0 to the derivatives does not change its marks, in this point an extremum is not present, actually. So if not change its marks, extremum, it's not present. So 4. Find value of function in the points of extremum. Example, to research on extremum function, f of x is equals to 2x squared plus 4x. Yes. Solution will be x prime equals to 4x plus 4. 4 prime on x will be 0. 4 prime on x from equals to 0. 4x plus 4. Here is the x will be minus 1. So we have some interval from the infinity to x lower or less than minus 1 line, and the minus 1, this interval from minus 1 to plus infinity. So we have two. You have one point when the x is equals to minus 1. It will be, the derivative will be 0. Yes, and the derivative when the x less than minus 1 will be, for example, minus 2, it will be minus 4. It decreases, and when it's the x is 0, for example, will be 4. The function will be 4. So on the first interval the function decreases, and then on the second will be grows. The function grows, and the result, the point minus 1, will be minimum. So at point of minus 1 will be minimum of the function. Meaning of the function will be minus 2. Yes. So at point of minus 1 the function has minimum minus 2. Yes. What in that way. Differential. Again, differential of the function in geometrical sense and application. So differential main linear exact interior from here part approximate value ring and external. Proceeding from definition of derivatives, x prime from limit from delta f divided on delta x, from delta x going to 0, by virtue of the theorem will be like delta f divided on delta x will be f prime on x respect of x and plus alpha x, whereas the alpha depends on x going to 0 and delta x going to 0. So it's some function what depends on x, but it's going to 0 very fast when the delta x going to 0. So multiplying both parts of equality I on delta x, we shall receive delta f it's equals to equals to f prime multiplying. Виктор Иванович, не шурши. Multiplying on delta x and plus alpha depends on x multiplying on delta x. The increment of the function delta f can be presented as two parts. the first part depends from delta x linearly, since f prime on x from delta x does not depend. In the second part, a on x depends from delta x. Then at delta x going to 0, the second part can be neglected, and the f prime on x multiplying on delta x will be a body of the increment of the function. So definition: differential delta f df over function, it's called the main linear part of the increment of a body of increment of the function. So df equals to f prime on x on multiplying on delta x. For the f depends on x function equals x, the differential is equals the x, it's equals to x prime multiplying on delta x, it's delta x. Therefore, from second e, it's possible to write down, so df equals to f prime on x dx. The application of differential for approximate calculations is based on the approached equality. Delta f is equals to df. So we have some also plot of the graph, Cartesian coordinate here on figure 6, and let's consider figure 6 from this triangle. Yes, delta triangle of M0 M K, and K equals to M0 K multiplying on tangent alpha. Yes, and it's equals to delta x multiplying of f prime on x, respectively, to nk will be df, differential f. So the geometrical sense of the differential is represent an increment of ordinate, yes, of the function y of the tangent to the graph of this function on the figure 5 and 6. What is our 5? The same, nearly the same, but we have the little bit another graph. Yes, the more curve, the distance between this m0 and m, it's big enough here, and we have some slope with the angle of alpha angle here, and we could receive the delta f df. Example: to find differential the y and the increment delta y for function y equals to x squared at x equals 20, delta x is equals to 0.1. So delta f will be equals to delta y, and there are two squared parts here, and we have the square sum, and when we open this bracket and doing some mathematical transformation, we will receive 2x multiplying on delta x plus delta x squared, and the result will be the 4.01. yes, and the df is equals to dy, it will be x power 2 prime multiplying on delta x will be 2x multiplying on delta x, it will be the 0.00. So in other words, the difference delta y minus dy minus delta y will be 0.01, and it is possible to neglect that delta y equals to dy. Yes, it's very near to the results. The delta y will be equals to your dy, and the less will be delta x. This differential between delta y and dy will be lower. So example, to find exact delta S and the approached value of the area of the ring ds on the figure 7. It is external radius, or it's equals to 17.02 centimeters, and internal radius is 17 centimeters. Yes, so this delta R is 0.02. It's the difference between two R, internal and external radius. Yes, there are difference 0.2 centimeters. The area of the circle will be PR squared, but we have to find the area of this not this ring ds. Yes, when the ray delta R is very small, so we have to make the difference between the first square from the external radius of R2 and the internal radius square, and the difference will be the 2.1 136 centimeters squared, and the ds will be PR1 squared prime on multiplying on delta R. So it will be 2p R1 multiplying on delta R, and the result will be 2.135 centimeters squared. So ds will be nearly equals to delta S. Their difference in the third sign after the comma, very small. Different function of the sinus and the power of 3 to x. The intermediate argument is u equals to sinus 2x. Y will be u in the power of 3. So the y prime, u in the power of 3 prime, multiplying on u in the prime of x in the ratio of x, and the y prime equals to 3 multiplying on sinus power 2 2x multiplying on cosine 2x multiplying on 2. So the result will be 6 sinus in the power of 2 2x multiplying on cosine of 2x. Yes, and the differential will be the same. Yes, it will be like y prime multiplying on dx. So the physical sense of the differential, as ds will be the multiplying on dt, the differential of a distance s is equal to the function of increment of a way which will turn out if to sum that since that given moment of time. Yes, the point goes in regular intervals, keeping the god speed. For example, if the speedometer of the automobile shows a 60 km per hour, the driver expecting that for 1 minute run of the machine will make 1 kilometer. So your car 1 minute run will make 1 kilometer. Actually calculates not increment of a way for 1 minute, which because of non-uniformity of motion cannot be equal to 1 kilometer, but differential of a way. So application of the differential for estimation of error. The true value of any physical size cannot be taken as a result of measurements, so experimental results obtained due to measurements usually contain errors. There are absolute errors and relative errors. The absolute errors is called the absolute value of the difference between the true and approximate value of a function delta y. Yes, it will be difference between fx plus delta x on fx, and the relative error is called the absolute value of ratio of absolute error to the value of measured value, epsilon delta y divided on y. Example, with the radius of a sphere has been found with accuracy till 1%. What accuracy of the given sphere volume? So given your delta r divided on r, it's 1%. Solution, we know that there is 4 divided on 3 pr cube, and the delta v is vr prime multiplying on delta r, and the result will be the delta v divided on v, the 2pr squared delta r, and 4 divided on 3pr cube, and the result will be 3 delta r divided on r. 3 multiplied on 1%, 3%. Yes, with the accuracy of given sphere volume, and the function of many variables will be the next. Goodbye. Okay, goodbye.